Radar plotting, part 5. The objectives for part 5, we're going to demonstrate and explain how to maneuver against multiple targets with a course change. 2, demonstrate and explain how to maneuver against multiple targets with a speed change. On an ARPA, this is simple. We just have to do a trial maneuver. But on a radar and using a plotting sheet, if we change course, we're going to change relative motion. If we change speed, we're going to change relative motion. So just because you cleared your danger target with a course change or a speed change, it's going to affect the relative motion of all your contacts. So just because you cleared one contact, it may put you in close quarters with another contact. So my first problem, find a new course, CPA and bearing a CPA. Required CPA is going to be 2 nautical miles. MX is going to be 12 minutes. How this is constructed is in part 1 of my video series. Then, using the new course we found above for the danger contact, for contact B, we're going to find a new CPA and bearing of CPA. MX is going to be 12 minutes. Before we get started, let's do a situational assessment, what we see on this plot on my radar plotting sheet. Our own ship is going due north at 20 knots. Contact A is heading westerly, and contact E is heading easterly. The rules say 2 power-driven vessels meeting as to invoke risk of collision. So far, there is no risk of collision. However, my company states that I have to maintain 2 miles around my vessel. So I have 2 close quarter situations developing. In contact A, this relative motion line is going to take my stern a little over 1 mile. In contact B, they're going to take my stern also by approximately 1 nautical mile. So it's my responsibility to open up my CPA. I can't ask somebody else to open up the CPA. So if we're heading north, contact B is going to be basically the giveaway vessel. We're going to maneuver against contact A, which is going to be a crossing situation since I see a port light and masthead lights on this vessel. So I want to execute a course change when the contact gets at 12 minutes. That's going to be MX, or the execution point. So I'm going to make a new relative motion line from MX just to miss the tangent of 2 miles. Then I'm going to change the triangle. I'm going to parallel MX, the M06, and draw that new relative motion line out to starboard. We're heading due north, so we're going to alter course to starboard. We're going to stab E, swing R to starboard, and label that R prime. You may label it RC for a revised course. The old course was from E to R, and the new course is going to be from E to R prime. To find out what this new course is, we need to parallel that to the middle of the plotting sheet. And this new course is going to be 038 degrees. So when contact A tracks down this relative motion line, they get to 12 minutes at MX. I'm going to alter course to 038 degrees, and they're going to start tracking down this new relative motion line, and I will take their stern by approximately 2 miles. If I make a course change on one contact, I need to make a course change on all the contact that's on my plotting sheet, because we may be developing a close quarter situation with another vessel after we make that maneuver. So I'm going to take this 038 degree course change and parallel it over to contact B. So we're going to be changing from due north to 038 degrees. So stab E, swing R to starboard. I'm going to label that R prime or RC for a revised course. If I change course, I change relative motion. So the old relative motion was R00 to M06. The new one's going to be R prime to M. So we're going to draw a new relative motion line, then parallel that down to MX. Then we can get a new CPA. And a new bearing of CPA. So by doing a 0 through a course change, I took the stern of contact A by 2 nautical miles, and I opened up the CPA from approximately 1 nautical mile to about 3.8 nautical miles. If we did not do a course change, we could do a speed change. So let's do a speed change on multiple contacts. This time our own ship's going to slow to 10 knots. We still have that required 2-mile CPA, and we want to determine what the new CPA and bearing of CPA will be, and MX is going to be at 12 minutes. Then we're going to apply that same course change to contact B to find out the new CPA and bearing of CPA. MX is still 12 minutes. This is the same situational assessment plot we had previously. This time, instead of a course change, we're going to do a speed change. We are going to slow to 10 knots. Find 10 knots on the 12-mile range scale, and we're going to parallel over to E in contact A. So that's my 10 knot speed change. If I change speed, I change relative motion. The old relative motion was R00 to M06. The new one's going to be R prime or RS for reduced speed to M06. Could draw a new relative motion line, then parallel that to MX. We can get a new CPA and a new bearing of CPA. So if I slow to 10 knots, I will take the stern of contact A. If I do if I do a speed change on one contact, I have to do it on all the contacts. So now we're going to slow down in contact B. So we're going to slow to 10 knots, label that R prime or RS for reduced speed. If I change speed, I change relative motion. Old relative motion was R00 to M06. The new one's going to be R prime to M. So I draw a new relative motion line from R prime to M06, parallel that to MX, and I get a new CPA and a bearing of CPA. This course change did little good for contact B. It opened up the CPA for contact A because I was going to take her stern by 2 miles. Before, she was going to take my stern by approximately 1 mile. Now she's going to take my bow by approximately 1 mile. I would have to come up a different speed change for me to be able to open up the CPA for both contacts. So to review our objectives for this part 5, we demonstrated and explained how to maneuver against multiple targets with a course change. Then we demonstrated and explained how to maneuver against multiple targets with a speed change.